In the last segment, we looked at like dissolves like and how important that is. For this class, we're just going to look at yes and no. Are the solute and solvent alike? If they are, they'll tend to mix. If they're substantially not alike, then they won't mix. In your next course, we'll look at the continuum, the kind of, sort of. That's how we get a phospholipid bilayer, the cell. Okay? This segment begins with other types of solutions, and an important type of solution is an electrolytic solution. An electrolytic solution contains electrolytes. What are electrolytes? These are ions in solution. So the question is, how do you know if you have ions in solution? Well, first of all, you want to understand matter of degree. If you have lots of ions in solution, that's called a strong electrolyte, and you get a strong current. And this is emulated by the light bulb shining brightly. If you get a few ions, that's a weak electrolyte, and you get a weak current, which is shown by the dim light bulb. If there are no ions at all, that's a non-electrolyte. The light bulb is dead. Now, how do you know whether you have a strong, weak, or non-electrolyte? Well, in general, you should know. How do you know if you have something that's ionic? In general, it's a metal plus a non-metal. Not always, but generally speaking. How are you going to know if that ionic compound is going to dissolve or not? Well, you're going to look at your solubility table. Okay, so for example, NaNO3 would be ionic because sodium is a metal and nitrate is a polyatomic anion. Your solubility table tells you that it's soluble. So you're going to have NaNO3, it's going to be solid. You're going to put it in some water, and it's going to be completely aqueous. What that means is it's going to completely dissolve into sodium ion and nitrate ion. So it's going to have about 100% ionization within the parameters of its ability to dissolve, which we'll talk about in just a minute. And the solution would have only ions. It would only have these ions in solution floating around with water in between. Lead 2 carbonate would be partially soluble. And the reason for that is that your solubility table tells you that it's insoluble. But insoluble doesn't mean a brick for all eternity. It just means that only some of it dissociates. So this means it's going to be a weak electrolyte, whereas this one's going to be strong. So I would write that as PbCO3 solid. I put that in some water. I get PbCO3 aqueous. A little bit of it goes forward to give me a few lead 2 ions and a few carbonate ions. Its percent ionization is low. So I'm going to have a lot of this and a few of these. So it's going to have both. CH3OH is non-electrolyte. And the reason we know is that this is a carbon compound. Carbon compounds are not ionic. So my CH3OH is actually going to be a liquid. It's not going to be a solid. And I'm going to put that in water, and it's actually going to be aqueous. It's actually going to dissolve in water. How do we know? Well, as a tangential aside, we know that's going to mix with water because of the polar bond here, is going to attract to the polar bond in the water. Okay, so its percent ionization is 0%. Would this have molecules, ions, both, or neither? It would have only molecules. No ions or at all. Okay? All right. Now, why do we care? From a body standpoint, why would we care about having an electrical current or impulse in our body? Well, we need it for our nerves, which tells our body tissues, our brain, our spinal cord, our body tissues, how to communicate, okay? And it tells our heart to contract, okay? So we need our nerves sending impulses so that we don't die, okay? So we need this to be alive, okay? And our muscles to contract, well, at the very least, we need that for our heart. Okay, so when the electrolytes in your body are disrupted, okay, one of the first things, for example, if you're sick, nausea, vomiting, you're very, very, very sick, one of the very first things that your practitioner will do for you is to stabilize your electrolytes. And the reason for that is if your electrolytes are really, really, really out of whack, you can really, really, really disrupt your heart function. Okay? Now, with that, our next unit will go back to solubility, but this time we're going to quantitate the extent to which we can get a solute to dissolve.